December 1894, 4:47 a.m. Saint-Léonard-de-Port-Maurice, Quebec. Arthur Sicard stands in the doorway of his barn, lantern raised against the pre-dawn darkness. The cold hits him like a physical blow, -38°C, though he doesn't know that yet. What he does know, with the certainty that comes from 3 generations of farming, is that something is wrong. The silence tells him everything. No shuffling of hooves, no warm breath misting in the frigid air, no low, anxious lowing of cattle disturbed by his presence. He steps inside. The beam of his lantern catches them one by one, 18 Holstein cows frozen in positions that suggest they huddled together, seeking warmth that never came. Their eyes are open. Frost crystals glitter on their nostrils. The Quebec blizzard that began 3 days ago has finally stopped, leaving behind snowdrifts that reach the barn's eaves and a silence so complete it rings in his ears. Arthur Sicard is 21 years old. These cattle represent 7 years of his father's savings, 2 years of his own labor, and the entire operating capital of a farm that has supported his family since 1823. In the span of one catastrophic winter storm, everything has changed. He doesn't know it yet, but this moment, this Pacific convergence of agricultural disaster and desperate necessity will eventually create an industry worth $200 million and fundamentally reshape how humanity coexists with winter itself. The problem facing Sicard isn't unique to him. It's a problem that has plagued northern agriculture since humans first attempted to domesticate animals in cold climates. Winter isolation. The blizzard that killed his cattle dumped 112 centimeters of snow in 72 hours. The drifts, sculpted by 40-kilometer-per-hour winds, created walls of packed snow 3 meters high along every road, lane, and pathway in the region. Quebec's road-clearing technology in 1894 consists of horse-drawn wooden plows and human labor with shovels. A crew of 12 men, working in shifts, can clear approximately 15 meters of road per hour when the snow is fresh. When it's wind-packed and frozen, that rate drops to 5 meters per hour. Do the mathematics. The distance from Sicard's barn to the nearest road is 400 meters. The road to the nearest town, Saint-Léonard, stretches another 6 kilometers. At optimal clearing rates, assuming the town prioritizes his farm, which it doesn't, help would arrive in approximately 6 weeks. His cows lasted 3 days. Sicard buries them in a snowbank that won't melt until April. Then he sits at his kitchen table and begins to sketch. What he envisions initially seems absurd. A machine that doesn't push snow aside, but lifts it, chews it up, and throws it entirely clear of the roadway. The concept isn't entirely original. Farm threshing machines, which he's operated since age 15, use rotating drums with metal teeth to separate grain from chaff, then blow the chaff away through a discharge chute. Sicard's innovation is to apply this same principle to snow, treating packed winter precipitation not as an immovable solid to be pushed, but as a granular substance to be processed. His first design, sketched in January 1895, calls for a front-mounted rotating drum with 4 curved scoops spinning fast enough to pick up snow and fling it into a secondary chamber where a fan blade, driven by the same power source, would blow it out through an adjustable chute. The entire apparatus would be mounted on a truck chassis. There's one immediate problem. The truck hasn't been invented yet. Sicard doesn't let this technical impossibility stop him. He adapts. His first prototype, constructed in the summer of 1896, is pulled by 4 horses and powered by a coal-fired steam engine salvaged from an abandoned sawmill. The rotating drum is built from oak barrel staves, reinforced with iron straps. The discharge fan is fashioned from sheet metal hammered over wooden forms in his barn. The contraption weighs 4,000 pounds and looks, in the words of his neighbour Jacques Beaumont, like something a madman would ride into battle against winter itself. In January 1897, Sicard tests it. The morning of the test, temperature hovering at -15, half of Saint-Léonard turns out to watch. They gather along the main road, where a snowdrift from the previous week's storm has hardened into a wind-packed wall roughly 2 meters high and 20 meters long. The town has been chipping away at it for days with shovels. Progress is measured in centimeters. Sicard fires up the steam engine. Black smoke billows from the stack. The horses, unaccustomed to the hissing and clanking behind them, stamp nervously. He engages the drive belt. The drum begins to spin. What happens next is simultaneously spectacular and catastrophic. The scoops bite into the snow. The drum churns. Snow rises into the secondary chamber. The discharge fan catches it and fires it directly backward into the steam engine's firebox. The coal fire sputters. Steam pressure drops. The machine grinds to a halt. Sicard sits atop his creation, snow melting in the residual heat, while the townspeople of Saint-Léonard politely applaud what they clearly consider a valiant but doomed effort. He makes 47 modifications over the next 3 winters. The discharge chute gains rotational capability. The fan blade diameter increases by 30%. The drive system switches from belt to chain to gear. Most crucially, he abandons the coal-fired steam engine, too prone to being extinguished by its own snow discharge, in favor of a gasoline engine purchased from a failed automobile venture in Montreal. By January 1902, Sicard's snowblower can clear that same 2-meter drift in 14 minutes. The horses still pull it, but now they need only provide locomotion. The engine does everything else, powers the rotating drum, drives the discharge fan, controls the directional chute. Snow arcs through the air in a continuous white stream, landing 20 meters from the roadway. The townspeople no longer applaud politely. They place orders. Sicard builds 3 machines in 1903, 7 in 1904. By 1905, he's operating a dedicated manufacturing facility, a converted tobacco barn, with 12 employees, and contracts from 4 Quebec municipalities. The machines aren't cheap. A Sicard snowblower costs $800 in 1905, equivalent to roughly 3 years' wages for an average labourer. But municipalities do their own mathematics. A single machine, operated by 2 men, can clear roads that would otherwise require crews of 30 working for weeks. The return on investment arrives with the first major snowfall. By 1910, every major town in Quebec operates at least one Sicard machine. The design has evolved. Pneumatic tires replace the original wooden wheels. The discharge chute gains a crank-operated rotation mechanism, allowing the operator to direct snow precisely. Engine horsepower increases from 15 to 35, enabling the machine to process wet, heavy spring snow as efficiently as the light powder of January. But Sicard's ambition extends beyond municipal contracts. In 1913, he approaches the Canadian Pacific Railway with a proposal: a specialized snow-clearing machine designed for rail lines. The railway, which loses thousands of dollars daily when tracks become impassable, orders 6 prototypes. These machines, mounted on rail cars and featuring extended discharge chutes to throw snow completely clear of embankments, prove so effective that by 1920, Canadian Pacific operates 47 of them across its network. The revenue transforms Sicard's operation from a regional manufacturer into an industrial enterprise. In 1922, he incorporates Sicard Industries with capitalization of $2 million. The factory expands. Employment grows to 200 workers. Production output reaches 120 machines annually. Winter, as Sicard understands, is not uniquely Canadian. In 1925, he ships his first export order, 12 machines to Finland. Sweden orders 30. Norway, 18. These Scandinavian contracts establish a pattern. Northern nations, tired of fighting winter with shovels and makeshift plows, embrace mechanized snow removal with the fervor of populations who understand precisely what's at stake. The American market opens in 1927, when the state of New York, facing pressure to keep the newly completed state highway system operational year-round, purchases 25 Sicard machines. Massachusetts orders 40, Michigan 32. By 1930, Sicard Industries exports more machines to the United States than it sells domestically. The company grows wealthy. Sicard himself becomes a figure of regional prominence. Mayor of Saint-Léonard from 1928 to 1932, philanthropist, investor in Quebec's emerging hydroelectric industry. But he never stops refining the fundamental design. The 1935 Model 40, his final major innovation, features a fully enclosed operator cabin with heating, a hydraulic system for adjusting cutting depth, and a two-stage snow processing system that can handle drifts up to 4 meters high. It weighs 12,000 pounds, generates 75 horsepower, and can clear a 2-lane highway at 15 kilometers per hour, throwing processed snow up to 40 meters from the roadway. This machine becomes the template for modern snow removal equipment worldwide. Arthur Sicard dies in January 1946, 3 weeks before his 73rd birthday. The obituary in La Presse estimates that his inventions have cleared over 2 million kilometers of roadway and saved countless lives by ensuring winter access to hospitals, emergency services, and essential supplies. The industry he created continues without him. Sicard Industries merges with Bombardier in 1954, forming what eventually becomes a manufacturing empire worth $200 million. The basic design principles established, rotating collection drums, powered discharge systems, directional chutes, remain standard in snow removal equipment 80 years after his first successful prototype. But the true legacy exists in something less quantifiable. Before Sicard, winter isolation was accepted as inevitable. Northern communities prepared for months of limited contact, stockpiling food and fuel, accepting that certain roads would become impassable until spring melt. Farmers calculated livestock losses into their seasonal budgets. Small towns maintained emergency supplies for populations that might be cut off for weeks. After Sicard, winter becomes manageable. Not eliminated, not conquered, but transformed from an overwhelming natural force into a logistical challenge with engineering solutions. Roads stay open, supply chains function year-round, emergency services maintain access. The economic and social geography of northern regions fundamentally changes because winter no longer dictates the terms of human habitation. 18 frozen cattle in a Quebec barn in 1894. 120 years later, municipalities worldwide operate thousands of machines descended from the device their desperate owner sketched at his kitchen table. The connection seems impossibly distant until you consider what links them: the specific desperation of a 21-year-old farmer facing ruin, the audacity to imagine winter as something that could be mechanically processed rather than passively endured, and the stubborn persistence to refine an absurd idea into practical reality. Sicard never forgot those cattle. Employees at the factory reported that he kept a photograph of the old barn on his office wall until the day he died. A reminder that innovation often emerges not from abstract problem-solving, but from the urgent specific need to prevent the next disaster. Winter still comes to Quebec every year. The snow still falls. The temperatures still drop. The blizzards still rage. But now the roads stay clear, and the cattle stay alive, and the silence of isolation has been replaced by the mechanical roar of machines processing winter itself, throwing it aside in white arcs against the grey sky. Arthur Sicard's revolution, born in grief and necessity, continues its work.